Welcome to session 5 of unit 2. This session we are still continuing with preparation of solutions, but this time round we are looking at the second aspect where you would actually prepare the solution, what goes into it. So let's proceed to look at our objectives for this session. At the end of this session, you should be able to write the dilution equation, calculate the dilution factor, then describe how to prepare standard acid solutions. Our first objective, we are looking at dilution of standard solutions. Now, when a solution is diluted, the total number of moles remains the same. Let's bring this down. Now, let's assume that you have half a bucket of water, and then you measure a cup of sugar into the water. Taste that solution and then take note of the taste. Now fetch another half bucket of water and add to it to make it a full bucket. When you do this, what are the things that will change in the solution? 1. The taste is going to change, meaning this time around you have a new concentration, and the volume is also going to change. So initially you had a higher concentration, so it was sugary. With a new volume, the taste has gone down, it's no more sugary, and then the volume initially was small. This time around you have a large volume. One thing that would not change is the quantity of sugar that you poured in this water. Once you have not added new sugar to it, the sugar before you added the water to the half bucket will be the same. So the number of sugar molecules in the concentrated solution or in the half bucket of water is the same as the number of sugar particles after you have added a half bucket of water. If that's the case, then we can say that the N of the concentrated solution is equivalent to N of the dilute solution. That's the basis for dilution. We have defined N as concentration times volume from the relation C is equal to N over V. So concentration of that solution when it was half the bucket times the volume when it was half will be equal to concentration when this time around we have added another half buckets of water to it to make it full times the new volume. And so that gives us the dilution formula. Now volume of the dilute solution is equal to the concentrated volume of the concentrated solution plus the additional water that we added to it. That will give us the volume of the dilute solution. We proceed to look at dilution factor, and with this we are talking about the number of times the volume of the concentrated solution is diluted. So the relation is given as dilution factor being equal to the volume of the diluted solution divided by volume of the concentrated solution. Sometimes you can define dilution factor in terms of concentration, and that one is going to be the concentration of the concentrated solution over the concentration of the diluted solution. So now that we know dilution formula, let's try our hands on this question. And the question is, what volume of 15 molar sulfuric acid solution should be diluted to 1 dm cubed in order to make 0.1 molar solution of the acid? In other words, or let's try to understand the question. Let's say somebody wants to prepare a solution, and the person has a concentrated solution with a concentration of 15 molar. The question is, what volume of this concentrated solution should he fetch such that when he or she dilutes or adds water to it to make 1.0 cubic decimeters, its concentration would be 0.1 molar of that solution. So, in other words, we have been given the initial or the concentration of a concentrated solution, that's our 15 molar, and then we have the volume that we are going to look for, which is not given. We have the final volume, which is 1000 cubic centimeters, and then the final concentration. Now, note that 1 cubic decimeters is equivalent to 1000 cubic centimeters. Now that we know that, let's go for our dilution formula. And for the dilution formula, we know the concentration of the concentrated solution, which is 15 molar. The volume of the concentrated solution is what we are going to determine. The concentration of the dilute solution is giving us 0.1, and that of the volume is 1000 cubic centimeters. So we do our substitution, make volume of the concentrated solution the subject, and then we have our answer there. So this 6.67 cubic centimeters is the volume that you are going to fetch if you are to prepare such solution. So you are going to measure 6.67 cubic centimeters and then dilute it till you get 1000 cubic centimeters. Such solution is going to have 0.1 molar concentration. Second example, this time around we have been given an assay, and the task is to outline how we would prepare 500 cubic centimeters of 0.1. In other words, prepare a solution that will have a volume of 500 cubic centimeters and its concentration will be 0.1 from the assay given. One thing that we have not been given is the concentration of the concentrated solution or our initial concentration, but we have the assay, so we can do that. And to do that, in the assay too, we were not given the molar mass, but since we know the chemical involved, which is hydrochloric acid, we can find its molar mass, and that is 36.5. Knowing the molar mass, we go for our relation. Concentration is equal to 10 times the density times percentage purity over the relative molecular mass. Then we put in our values. That gives us 11.64. So that stock solution, out of which we are going to pick a certain volume, has a concentration of 11.64. So with that, what volume should we fetch is now what we are going to look for. So once again, we state our dilution formula, and then we do a substitution where the concentration of the stock solution is 11.64. Volume is what we are looking for, and on the other hand, concentration of the dilute solution is what has been given as 0.1 with a volume of 500. So we make a volume of concentrated solution the subject, and we have the volume there, which is 4.296 cubic centimeters. So this is the volume that we are actually going to measure. Then we will dilute such solution. So knowing this and having this information at hand, you proceed with what to do. And with what to do, first of all, you measure the volume that you have calculated. So here we are approximating it to 4.3 cubic centimeters, and you use an appropriate volume measuring instrument. Don't go and take an instrument that will measure 100 cubic centimeters or 1000 when you just want to measure just 4.3. That will introduce a lot of errors. So just pick a small instrument, which is the 10 cubic centimeters measuring cylinder. Measure that volume, and then when you measure that volume, you see we don't add water to acid, but rather acid to water. So before you proceed with this, you first have to get your metric flask and then add some distilled water to it, such that the volume of the acid you have added, you are going to add it to water in the volumetric flask rather than pouring it first and then adding your water. Such reactions are exothermic, and in some cases they might cause explosion. So you do that, and now that you have small volume of water in the volumetric flask, you transfer the volume that you have measured, the volume of the hydrochloric acid, into the volumetric flask. Because you have done calculations and you want everything to be accurate, you still have to rinse the measuring cylinder such that you get all of the hydrochloric acid into the volumetric flask. If you don't rinse, remember you have reduced the volume and that will affect your final concentration. So rinse and then transfer to the volumetric flask. When you have done that, what is left is to now add more distilled water till you reach the mark on the volumetric flask. Remember, volumetric flask, they are used to measure fixed volumes. So if it is 500 cubic centimeters that you want to measure, you pick the flask that measures 500 cubic centimeters, because there is only one mark on the neck, and that is the 500 cubic centimeters mark. So when you top it up, remember we are dealing with meniscus. So when it reaches that point, you have prepared such solution of the given concentration. So we are ending the session with a question or a task for you. Please try it, and let's meet in the next session. Thank you very much.